Now that we have a good handle on graphing sine and cosine functions, let's move on to the graphing of a tangent function. So our essential question today is, how do we graph the tangent function and what are those properties? So first, let's begin just like we did with the sine and cosine graph. Let's use the unit circle to find the value of the tangent function at certain common angle measures, which would make it so much more simpler for us to graph the tangent function. So in the table provided, you will see that we have some selected angle measures, and we need to remind ourselves that the tangent of any angle is the quotient of y divided by x. We'll always divide the y coordinate by the x coordinate. So let's look at angle 0. So at angle 0 degrees, we look at y divided by x, and in this case, our y was a 0 and our x was a 1. 0 divided by 1 would give us a 0. Then we move on to angle 45 degrees, or pi over 4. Now at the 45 degree angle, we have square root of 2 over 2 and square root of 2 over 2. When you divide y divided by x, you're going to get a 1. Both numbers are identical, so when you divide by itself, it's going to be a 1. At 90 degrees, or at pi over 2, y divided by 0, 1 divided by 0. Well, we have an undefined value. We don't divide by 0, so we will write undefined. And as you continue moving around the circle, rotating about it, you will continue doing y divided by x, and you will generate the following answers. You would have also another undefined value at 270 degrees, and notice how the pattern continues to unfold. Okay? Now, at these undefined values, we have an important role of a certain property of a tangent function. At these undefined values, we are going to have what are called vertical asymptotes. So you'll have a vertical asymptote here, and you'll have another vertical asymptote here. And these are key in helping us graph our tangent function. Okay? You are going to notice that from one vertical asymptote to another, so for instance, from this vertical asymptote of 90 degrees to 270 degrees, there is a difference of 180 degrees, or pi radians. What I want you to know is that this actually is the length of one period, one cycle of our tangent function. It's going to be pi radians. So let's take these values and come over here to the right, and let's plot them on this coordinate plane. So the first thing I want you to do is let's divvy up this x-axis. I'm going to do these by radians. This is going to be 2 pi. And if we look for a halfway mark here, pi, this would be pi over 2. And here would be 3 pi over 2. And we'll do the same thing again. 2 pi, pi, and these will be the negative values. So we have negative 2 pi, negative pi over 2, and negative 3 pi over 2. And on the y-axis, let's go up a certain distance, 1 and negative 1. So we'll be counting by increments of 1 and negative 1. Okay, basically. Okay, so all we've done is label our x and y axis, and we're going to plot the values found in the table. And I guess I should have stuck to labeling my angles with degree measures, but a lot of the homework is solely in radians, so that's why I went ahead and changed it. So if you would just look at the unit circle, if you have forgotten your radian measure, 45 degrees is just pi over 4, 90 degrees is just pi over 2, and so forth, okay? So let's go to plot these numbers. Whoops, did not mean to move this graph. There we go. Okay, so let's plot these values. So the first one was 0, 0. So we're going to put a 0, 0 right here. And then we had 45, comma 1. Well, our 45 degree is pi over 4. And pi over 4 is somewhere right in the middle of 0 and pi over 2. Okay, halfway. So 45 degrees, and it was at 1. So I'm going to put a 1 right here. And then at 90 degrees, or at pi over 2, we had an undefined value. So I'm going to use my ruler right here, and we're going to draw a vertical asymptote at that value. Vertical asymptotes are always drawn with vertical dash lines, okay? And then we have a 135 is -1. Well, at 135 degrees, we are at 3 pi over 4. So this is 1/4, 2/4, so 3 pi over 4. We're at -1, they said. So it would be around right here. And then we had 180 is at 0, which is at pi. And then at 225, we're at 1. Well, 225, look at your unit circle. It's in between 180. So here's 225. And it's halfway between 180 and 270. So 180 and 270 halfway is around right here. And we're going to go up to +1. And then, whoops, that dot's a little bit overwhelming. Here's at +1. And then again at 3 pi over 2, which is 270, we have another vertical asymptote. So let's go ahead and draw this other vertical asymptote. And notice that there's going to be a pattern happening, because at 315 we're back at -1. And then at 360 it's a 0, and so forth. So what you're going to notice is at every 180 degrees, we are going to have a vertical asymptote happening. So I'm just going to draw another one right here for our negative values. And I could draw another one right over here. Okay, because the pattern is going to continue. It's periodic. So here are my vertical asymptotes. And I want you to notice these dots, how they will be drawn as far as the tangent graphs. You start with this middle dot right here at pi, and you connect it all the way up. And the arrow goes up, and it goes all the way down. They look like cubic functions, okay? They look like cubic functions. So this one's going to go all the way up. And based on our pattern, we would have had a dot right here. So it's going to be all the way down. And it gets really, really close to our tangent function. I mean, not to our tangent function, to our vertical asymptotes. So I'm going to repeat the pattern. I know there's a dot right here, halfway between -pi over 2 and -pi. It goes up to 1. And halfway between -pi over 2 and -3 pi over 2, it goes down to -1. And I am going to curve up. And I'm going to curve all the way down. So our tangent function looks like that. So I think you can pretty much picture what's going on here. So how can we take this information to help us graph our transformed graphs, knowing what our tangent graph looks like. So again, this here is y equals tangent theta. That's what this graph is all about. Okay, so one thing I want you guys to notice about this graph is that unlike the sine and cosine graph, the tangent function has no min or max value. And since it has no min or max value, it has no amplitude. Okay, so anytime you are asked to provide the amplitude for a tangent function, I want you to please write none. Okay, we do not have an amplitude for a tangent function. Okay, notice also another feature I want you to notice is the period of our tangent function. The period is the distance between any two consecutive vertical asymptotes. Okay, so however far those two vertical asymptotes are from one another, that's going to be the length of their period. Okay, so notice in our graph, I'll do it in green here, the distance from here to here is 180 degrees. The distance from here to here is 180 degrees, or pi radians. Okay, that's what I mean by that. So let us move on to two practice problems. So here is our first one. Y equals 4 tangent 2 theta minus 1. And if you prefer writing it in a different manner using x instead, I'm sorry, enlarge this again. If you prefer writing it as y equals, y equals 4 tangent 2x minus 1, feel free to write it that way as well. Okay, the theta and the x mean the same thing. Now, we are still, our format, by the way, of our graph is still going to look like, not of our graph, of our equation. Y equals a tangent bx plus c. That still is going to be our format. Okay, so in this problem, let us go ahead and identify what our a, b, and c is going to be. Okay, so let's start out here. Our a value is our 4. Our b value is our 2. It's in front of our theta. And our c value is a -1. So the first thing I want you to do is identify the amplitude. We have already just discussed that amplitude for tangent functions are always going to be a none. Do not confuse the a value that you see upstairs here. Don't confuse that with amplitude, okay? Now, to calculate your period for tangent functions, instead of 2 pi over b, as we've done it in sine and cosine, it's going to change to pi. Pi, because that's the length of the period of our parent function, pi over b. So in this problem, our b value was a 2. So pi divided by 2 is the length of the period of this graph. So from one asymptote to the next, it should be pi over 2 long. Now, since we know that the length from one asymptote to another is pi over 2, let's figure out the equation of the first asymptote. So let's call it asymptote number 1. Okay? Asymptote number 1 can always be found by this equation. B times x equals pi over 2. And you are going to solve for x. Okay? Well, we know our b is a 2. So 2 times x equals pi over 2 is the equation that I'm needing to solve for. So what do I need to do on both sides? Well, I need to divide by 2 on both sides so that I can cancel out these 2's and solve for x. Pi over 2 divided by 2 is the same thing as saying pi over 2 times the reciprocal of 2, and the reciprocal of 2 is 1 over 2. So my first asymptote is going to be located at pi over 4. So here is the first asymptote. So we're going to come over here, let me get my ruler, and let's go to pi over 4. So here I put a dashed line right through pi over 4, and there is my first vertical asymptote. Asymptote number 2, I'll come over here, let's do it in like a slight pink here. Asymptote number 2 is always going to depend on the answer you found in asymptote number 1, because the equation for asymptote number 2 will be x equals asymptote number 1 equation plus the length of your period. Okay, so asymptote number 1 was pi over 4 plus the length of your period, you found it at the beginning to be pi over 2. Now, to be able to add these two together, our denominators need to have common numbers. We need common denominators to add fractions. So the common denominator between a 4 and a 2 has to be a 4. So I'm going to multiply this by 2 to get my common denominator. So pi over 4, this fraction was okay because it had a denominator of 4, and this one becomes 2 over 4. So x equals 3 pi over 4 is the equation of my second asymptote. So I'm going to come over, I'm going to come over here at x equals 3 pi over 4, and we will put the other asymptote. And we'll put the arrows. Okay, now remember on sine and cosine, you guys would always plot 5 dots to be able to connect your dots to make the curve for sine and cosine. Well, here you're also going to connect 5 features, but the combination is not going to be 5 points. It's going to be the 2 vertical asymptotes and 3 more points in between these vertical asymptotes. So we have already found 2 of the 5. How do you find the 3 points in between these 2 vertical asymptotes? Well, here's how you do that. So the first thing you're going to do is you're going to find the halfway mark between the first 2 asymptotes. Okay, so the first step is find the halfway mark. The halfway mark between pi over 4 and 3 pi over 4 is somewhere around here at pi over 2. Okay, now I know that my C value is -1. My C value tells me what my vertical translation is. Okay, it tells me if my graph has moved up or down. So based on -1, I know that my parent function dropped down 1 point, or dropped down 1 unit. So I find my halfway mark. You always find the halfway mark between these 2 vertical asymptotes, and then go use the C value to plot your first point. So my C value, here's my halfway mark, and I'm going to go down 1. So right here is where I'm going to put my first dot. Okay, right there I'm going to put my first dot. So first point, how do you find it? Well, you locate the middle of both asymptotes and use your C value for any vertical translation that has happened. Okay? So we found the middle and we went down 1. Now, for your second point, what you're going to do is find the middle again. So I'm going to put the notes here again. Second point, find the middle between 2 other things now. You're going to find the middle between your first point and your right asymptote. And once you know the pattern, it doesn't matter if you do right or left first, okay? And then you're going to use your A value. Okay, so what do I mean by that? My halfway point is right here, okay? Right here where I've made this black mark. And I'm going to place my dot right there, but then I'm going to use my A value to graph my point, okay? So let's do that. So I start here in the middle, and then I go up 4. 1, 2, 3, 4. And I'm going to put my dot right here. Okay, so I started right here, and I went up 4. 1, 2, 3, and then I put that dot there. Okay, and then I'm going to do the same thing, but in the opposite direction. I'm going to go in the middle between my dot and the other asymptote, which is right here where I'm marking. And this time I'm going to count downwards 4 units. Okay, so I'm going to go 1, 2, 3, 4 units. And again, I'm using my A value. So I'm going to write down here in the notes for third point, just do the reverse of what you just finished doing. Okay, and so once you've got those 3 dots, you connect them. Whoops, oh, that's just horrible. So you're going to connect them just like you did with your parent function. And they get awfully close. I'm going to try and do that a little bit better for you. You get them really, you just try to curve them so that they get awfully parallel and awfully close to that other asymptote. And since now that I know the pattern, so I got 3 points and 2 vertical asymptotes, I can come along and just make a couple more vertical asymptotes because I know the period length is pi over 2 units long, right? And then in between these, I can just imitate what I did with the first one. 1, 2, 3, 4, and just connect the dots, and you're done. Wrong side. So right here, 1, 2, 3, 4. Go to the middle, 1, 2, 3, 4. And if you do, 1 or 2 cycles, it's enough. Okay, here I did 3. And that's it. You're done. So again, you had plot this point first, 1, plot this one, 2, and plot this one, 3. And once you've done that, you just repeat the pattern. Okay, let's try one more here at the bottom. Let's scoot this up. And we will start with finding our A, B, and C. So A is a 3. That will always be the coefficient of your trig function. B is the coefficient of my x or my theta. There is an invisible 1 right here in front of my theta, so B is 1 over 3. And C is -2. Okay, so we start off. Amplitude, super easy, always write none when it's a tangent function, okay? Period, the formula for period is pi divided by my B. In this case, it's 1/3. Pi times the reciprocal of my B ends up 3 pi over 1. So my period length is going to be just 3 pi. It's 3 pi divided by 1 is 3 pi. Okay, and make that a little better. There we go. Now let's go towards our asymptote. So asymptote number 1. Okay. Asymptote number 1 says that the formula will be B times your x equals pi over 2. It's always going to be pi over 2 because pi over 2 in essence was your first vertical asymptote. If you recall, I'm going to go back up here a second so you can see what I'm talking about. Right over here where it was undefined, right? That was our first asymptote to be undefined. So we use that as our gauge. So our formula, bx equals pi over 2. Our b in this problem was, let me bring that down, 1/3. So I'm going to put 1/3 equals, 1/3 x equals pi over 2. I need to divide both sides by 1/3 so that I can isolate my x. And now my x is all ready to be isolated. And so x equals the top fraction, pi over 2, times the reciprocal of the bottom fraction. Pi times 3 is going to be 3 pi, and 2 times 1 is going to be a 2. So here is the equation of my first asymptote. So let's come over here, get the ruler, go to 3 pi over 2, and this is the first of the 5 characteristics that help me draw out my initial period of my tangent function. Let's go find asymptote number 2. Asymptote number 2 depends on you finding asymptote number 1. So x equals your initial asymptote, which was 3 pi over 2, which is the previous answer, plus the length of my period, which in this case is a 3 pi. And again, we need to get common denominators. So let's do that. X equals, the common denominator is going to be a 2. So we already have a 2 on this one. This other one has an invisible 1 underneath it. So I need to multiply top and bottom by 2 in order to convert it into 6 pi over 2. So x equals 9 pi over 2, and this is my second one. I like when it gives me a, there we go, 9 pi over 2. So we're going to come over here, and this one's going to be a really wide one. So 9 pi over 2 is where I'm going to put, I didn't mean to scoot it over that much. Whoops, everything's moving on me. And let me take that ruler away for a second. and put my arrows. So now I have 2 of the 5 things that I need. And now what do? Well, backtracking again, it says over here that when I'm looking for my first point, I need to locate the middle of both asymptotes, and use the C value. So the middle of my both asymptotes is right here. And my C value is a -2, which means that I'm going to have to count down 2 units down. So let's do that. Find the middle and go down 2 values and put your dot. There's my first dot. And then it says find the middle between the first point and the right asymptote. Well, the middle of the first point and the right asymptote is right about right here. And my A value is a 3, so that means I'm going to count 3 up in this direction. So let's do that. So I start 1, 2, 3. And then I do the same thing on the other side. Find the middle between the dot and the asymptote, and this time I go downwards in my counting. So I'll go down 3 units of A value. 1, 2, 3. And notice, please, that you will always notice that the 3 dots will always line up. See how these 3 dots line up? They will always line up. Okay, so I connect these dots into a curve where I get closer and closer to that asymptote, and I'm done. So the other dot was 3 units away, so 1, 2, 3 down, like here's the other one right here. Halfway, 1, 2, 3, 4. No, not 4, 3. Right here, and we can connect. And the others obviously go on to the other side, so we can't see what's going on. But that's all you do. That's how you graph a tangent function. Hope this helps you complete your 4 problems for your homework.